In this episode, intro to sets, language notation element subset. Coming up, back into action. Hey guys, today I will be introducing sets, set concepts, language notation elements, subsets, and all these things related to sets. Now, what is a set? Well, roughly speaking, set is a well-defined collection of objects or things that are typically called members or elements of a set. Let's take a look at example. Suppose you are given set, let's say A, which has the following elements. Well, typically, the capital letters such as A, B, C, X, whatever, are used to represent sets. So this is kind of the name of the set. Now, whereas the lowercase letters, small letters, could be A, X, B, whatever comes along, are used to represent the elements or the members of your set. Typically, we use the curly brackets or the braces to write sets explicitly. And typically, we enclose the elements of the set within these braces, and we separate them, so they are separated by commas. You write that element 1 is in a set A, or in other words, element 1 belongs to a set A. It's written this way, and this symbol, it's basically a letter from a Greek alphabet, epsilon, that basically indicates this fact, this relationship between an element and a set. So this fact you could either read as 1 is in A, or 1 is in A, or 1 belongs to A, or just 1 in A, for sure. Whereas the element 70 does not belong to a set A. So you just cross this symbol of this relationship. Why? Since 70 is not in our set, we have the sequence of natural numbers from 1 till 6. And as you can see, 70 is not there. Now, a little remark. Normally, usually, we do not duplicate the elements of the set. So each element has to be listed just once. So if you write something like A equals, let's say 1, 2, 2, and 3, you can see the element 2 is listed twice. So this is incorrect notation of a set A. So since the element is duplicated, so we normally write one element one time. Another little remark, that the order of the element does not matter. It wouldn't matter. So you could, instead of this, just write your A is 1, 2, 3. It's the same set as you can swap the order of your elements. Let's say you can swap 1 and 2, and you could write just 2, 1, 3. or even more. You could swap any other elements and write like this. It's precisely the same set. So no matter the way your elements are written in your set. Now, moving on. Sometimes your set has no elements and it might come up. And there is a special name for this set. It's called empty set, since there is no elements. It's like empty basket. There is no elements in it. So, and there is a special symbol. It's usually denoted by this kind of circle, and you cross it. Or you might come across another notation. It's just curly brackets and inside empty, nothing. So it's same thing for representing empty set. And talking of empty set, I want to give you just a quick example on this. Let's say you have B that has the elements all pigs that can fly. Well, we know pigs, and we know that pigs are not able to fly. So that's nonsense. So there is no pigs, we cannot find pigs that can fly. So this set B is an empty set, since there is no flying pigs in this set. So this is the basically empty set. You could come up with other examples of empty set, especially in maths. For example, it could be set C that has all these elements x from the set of real numbers. So this capital kind of bolded R is taken to mean the set of all real numbers that satisfies the equation x squared plus 1 equals 0. And since x squared equals -1, there is no real solution. I'm just emphasizing that no real solution, because if you go to a complex field, there are solutions, and it's I and -I, but this is another story. So in this case, there is no real x values. There is no real x solutions or roots that satisfy this equation in a real set. So this set is also an empty set. Alright, the last thing I would like to cover here is the idea, the relation of a subset. Let's have a look at example. Let's say you are given set A that contains the following list of the elements: 2, 3, and 4. Just let's put it simply. And you are given set B, which has the following elements: 1, 2, 3, 4, and 5. Now, as you can see, each element of a set A, namely 2, 3, and 4, is an element of a set B. So 2 belongs B, 3 also is in B, and finally 4 also is in B. B has all of these elements. So we could say in this case that A is a subset of a set B, or in other words, A is included in B. And there is a special notation for this fact, for this relation. It's a special relation between these two sets, and it's usually denoted by this symbol. So it's very similar to the relation between the element and the set that I gave you at the beginning of this episode, this is different story. This is the relation, do not be confused. This is the relation between two sets. So again, that simply means that each element of the set A also is an element of a set B. So in this case, we would say A is included in B, or B includes A, or B contains A. Also, B sometimes is called a superset, since A is completely inside of that B. Well, to be perfectly honest with you, it kind of reminiscent. It might remind you the relationship between numbers, the less than or equal to. It looks like similar if you look like 1 is less than or equal to 2, let's say, or less than. So the symbol that stands for this inclusion, the relation inclusion, it's very similar to that one you might see. If that's not true, if it's false, if it does not satisfy, we could simply just cross this symbol of inclusion, just cross it like this. Now, little bit remark over here, sometimes instead of this symbol, book or might be your teacher use this symbol, but it has to come that some agreement at what should you understand when you use this symbol or that symbol. So like it has to be no like ambiguity, it has to be clear. Basically, little line over there means that your A and B might coincide, it might be the same set. So again, it's kind of similar to this one. But if we are using this symbol like strictly, like, and write it like this, that means there is no case, there is no way that A might be equal to B. So that simply means A in this case cannot be equal to B. So as I said, other books or your teacher, instead of this symbol, they might use that symbol. But instead of this, in our sense, they might use kind of this symbol. That means it's not equal over here. So again, it comes to just to notation and kind of agreement that can be said, can be done at the beginning of your course or lecture. That X that contains the following element. So I'm wearing t-shirt now. I'm also wearing this shirt. Now let's say you said Y is all items you wear. So since I'm wearing, you could see, short, t-shirt, okay, let's say shoes, and yeah, let's say socks. So we would conclude that set X is the subset of the set Y, or set Y is a superset, set Y contains, includes set X. Well, I hope it was helpful and you had fun, so much fun. Thanks for watching and train your brain. I know everyone hates math, but if you like my video, please hit like, share with your friends, leave the comment down below and make sure to subscribe so you will not miss out my new